Hi, I'm Ian.
Hi, I'm Yan-Han.
Hi, I'm Hilman.
And we are
Einsteinium.
Today, we're going to show you how helium neon laser works.
Okay, so this is the simplified version of the laser. This part here is the discharge tube. One end of the tube is the full reflector, the other end is the partial reflector, and as you can see inside, the marbles represent the helium and neon atoms inside the discharge tube, and the pens here are the discharge electrode. And what's going on inside the discharge tube is inside the discharge tube there will be helium and neon atoms, and an electric discharge passes through the gas and collide with helium and neon atoms to excite them. So basically they're just getting excited and become active, and at the same time excited helium atoms, the batch here, will also transfer its energy to unexcited helium neon atoms to a metastable state. So these helium atoms will help neon atoms to achieve population inversion, and as a fraction of times later, excited neon atoms will spontaneously emit photon out of its atom, and neon atoms will back to its ground state.
Population inversion is what that happens when there is more high energy level atoms than low energy level atoms. This phenomenon can be achieved through pumping. In order for laser to work, we need to have more high energy level electrons in the atom than low energy level electrons. Imagine this marble is the electron inside this atom. This can be done through a process called electrical pumping, where light is continuously used to raise the electrons in the atom to a higher energy level so that we can have more high energy level electrons in the atom than low energy level electrons.
The pink ball represents the excited atomic electron. The blue marble represents the photons. So, stimulated emission is the process of incoming photons of specific frequency intersect with an excited atomic electron, causing it to move to a lower energy level. After the interaction, it will emit new photons with phase, frequency, polarization, direction that are identical to the stimulated photons, which is coherent and monocrotic. In the tube, the photons will be reflected by the mirror back and forth, and eventually some of the photons will pass through the partial reflector as laser.